how it works is you have confidential data, you have private data that developers share with you. And what you're trying to do is you're trying to build a distribution curve based on that data. And so I'm about to oversimplify our business in an unhealthy way for the sake of making it straightforward. So bear with me. But imagine that like you're trying to build an estimation for the travel category, right? And you have 1,000 apps that share their real data with you, JetBlue being one of them. What happens is you're taking JetBlue's data and you're almost graphing it on a scatter plot and saying, when it was ranked second in Canada in travel, it got this many downloads. When it was ranked 18th in the US, it got this many downloads. And you're building a scatter plot of all these data points of every travel app in your database for every day that you've had it for every rank. And then what you're doing is you're building like a best fit distribution curve for that scatter plot. And what that distribution curve is saying that on average, when an app is ranked third in the travel category in Mexico, here's what their performance looks like. And that is like piece one, which happens here in a box. Piece two happens in a separate box, which is you feed inputs to the model. The inputs to the model are publicly available metadata points. So your model might say, hey, I want to produce an estimate for this app ID. That app ID would be JetBlue. It's a travel app. I'm producing an estimate for the US. Its rank yesterday was Y. It had, so now what the model is doing is it's taking publicly available data and it's finding the place on this distribution curve that makes the most sense. So, you know, maybe it's saying because it's ranked 7, it's right here on the distribution curve. Well, JetBlue was released 10 years ago, so we're going to bump it up 3% from the average because of this other metadata point. But the point that I'm trying to make, and sorry for being a little geeky, is that you use the confidential data to build the distribution curve. But then when you're actually producing an estimate, all you're doing is you're using publicly available data to find where on the distribution curve that should be. Right. Now, the delta in what App Annie was allegedly doing was that they were actually using the real JetBlue data as an input to the model, right. Not just training a distribution and then using publicly available data. They actually fed the real data into the model, but the feature said only do half of the value, right? Hypothetically.